First of all, a very good morning to everyone. So today we are going to discuss the chapter named Dual Nature of Radiation and Matter. In this chapter also particularly I will be discussing about Hertz and Lenard's experiment. We basically remember this experiment as photoelectric effect. So first of all, let me give you a very brief introduction about this experiment. So as we already know about wave nature of light, there are various evidences which proves us about the wave nature of light. For example, Maxwell's EM wave equation and also Hertz experiment. So in earlier time, an experimental research on conduction of electricity through the glasses at low pressure were going on. During this experiment, what was observed that fluorescent glow on the glass tube opposite to the cathode. See, we are having in this experiment also we are having a cathode and anode. And this is an evacuated glass tube. Evacuated glass tube, what does that mean? It means that there is nothing inside this glass tube except the electrons. So at that time, what was observed that a fluorescent radiation was observed. So this fluorescence coming from the cathode side was observed. What was this fluorescence coming from the cathode side? This fluorescence later on it was named as electrons, as they were nothing else than the electrons. Electrons means they were negatively charged particles. Then comes Hertz into the picture. What were the observations by Hertz? Hertz made some observations, like he observed that when light falls on the metal surface, electron escapes free. So how does this electron escapes free? As electrons near the surface absorb some energy from the incident radiation, and after absorbing this amount of energy, when the surface absorbs sufficient amount of energy, then the electrons escape from the surface. This was observed by Hertz. Then Lenard comes into the picture. What were the observations by Lenard? Lenard observed that radiations falling on the emitter plate of the glass tube, if the radiations fall on the emitter plate, what happens that the current starts flowing, which was later on named as photoelectric current. So what happens is that the light from any source when falls on this cathode, when light falls on this cathode, then the electrons on the upper surface of this cathode plate, they get excited, and these electrons, when get a sufficient amount of energy, they are emitted out. What is this sufficient amount of energy? If these electrons absorb some amount of energy more than their work function. What is work function? Work function is defined as the minimum amount of energy which is required to pull an electron out from the metal surface. This is known as work function of the metal, and this work function is denoted by phi naught. So when the electrons on the upper surface of this plate get energy more than their work function, then they are emitted out, and these electrons, they travel towards anode, the collector plate. As this plate is collector plate, the electrons from here, they travel towards this side and then flows through the circuit, and then they comes to this commutator. What does this commutator do? See, this commutator, in this we are having two switches. If this switch is connected to this one, and this switch gets connected to this one, the circuit completes, and the direction of flow of current becomes this. So what does this mean? That if direction of flow of current becomes this, then the flow of current is in positive direction, because here we are having this positive terminal. And otherwise, if this commutator rotates and this switch connects here and this switch connects here, so what is this? Now this switch is connecting here, so what is this means? This is connecting here, so the flow of current becomes in this direction. So what happens that if the flow of current becomes in this direction, then the flow of current becomes negative, because here it is connected to the negative terminal. Okay, so this is the sequence, the way we are going to discuss things. First of all, we will be discussing about the effect of intensity of light on photocurrent. So in this section, first of all, what we will be doing is that we will put voltage to a constant value. Then we are going to vary intensity and note the effect of intensity on the photocurrent. Okay, then we are going to study the variation of intensity and current. Then secondly, we are going to discuss the effect of potential on photoelectric current. In this section, what we are going to do in the above section, what we have done, we have put this voltage at a constant value, but here we are going to vary the potential, and also here we are going to vary the intensity and put frequency to a constant value. And we are going to note the effect of putting intensity at of varying intensity and putting frequency at a constant value, the effect of both of these on the potential of collector plate potential is we are going to see the effect. Then third, in this third section, the effect of frequency of incident radiation on stopping potential. What we are going to do here is, first of all, we will put intensity. What we are going to do with the intensity, first of all, as in the above section, we have varied the intensity, but in this section, we will put intensity to a constant value. We will vary frequency. Frequency we are going to vary. And what next? Potential. In this section also we will vary potential. And we are going to note the effect of this varying frequency and constant intensity again on this voltage, and we are going to see what comes in the result. Then we are going to discuss about threshold frequency. Then at last I will be discussing these the outcomes of photoelectric effect. Then we will try to understand this photoelectric effect through wave theory. Then we will proceed towards why this wave theory failed to explain the photoelectric effect. So here comes our first section, that is effect of intensity of light on photocurrent. So first of all, let me tell you what does we mean if we say we are varying frequency. What does we mean that if we are varying frequency, we means that we are changing color of light. Color of light is changed. Color of light means we are changing source of light. Source of light. That means source of light can be of any radiation. Here we are talking about UV visible light because photoelectric effect is most effective in this region only. Otherwise we can take any light in microwave region or beyond that. We can use any source of light, but particularly here we are talking about UV visible region. And that is, we can if we talk about color, wavelength also comes into the picture. If we say that we are changing color, that means we are changing wavelength. And if we are talking about intensity, if we say we are varying intensity, what does that mean? Like let me take an example from real life. What do we say? That if there is a small child and he is having fight with someone who is more heavier, more powerful than him, so what does he do? That he calls his brother or sister, as someone elder than him, someone more heavier than him, to fight with him. Why does that child does so? That is because he knows that someone more heavier than him will be having more power than him. So he thinks that someone more heavier, someone more elder, he will be having more power. So he also thinks in terms of power. So if we relate this example with this theory, so what do we get? That if I say I am having a 100-watt bulb and I am also having a 200-watt bulb, so we say that intensity of a 200-watt bulb in comparison to a 100-watt bulb is more. So why do we say that? Does that mean amplitude of 100-watt bulb is more than 200-watt bulb? No. Amplitude is more, but amplitude does not affect intensity of light. If I am talking about intensity of light, I am directly talking about power of the bulb, or I can say I am talking about energy of the bulb. if I take a 200-watt bulb instead of a 100-watt bulb, then I am directly saying that I am having a more powerful bulb now than I was having earlier. That is, I am having a 200-watt bulb which is having more power than a 100-watt bulb. So if I am saying it is having more power, that means it is more intense than the earlier bulb. So this is what we mean by varying frequency and varying intensity. So now let us come to this experiment. So what we have to do here is we are putting some amount, some intensity on the cathode. So if we are putting a certain amount of intensity, what we are getting? We are getting a certain amount of current. But now if we increase this intensity by, say, if I am using this intensity, I am doubling this intensity. For example, earlier I was having a 100-watt bulb, now I am having 200-watt bulb. So what will happen? The current will increase, the photocurrent will increase, because now I am using more powerful bulb. But if now again I increase this power, so what happens? Again the photoelectric current increases. What this graph is telling me, this graph is showing that there is a linear increase in intensity and intensity of the bulb, and also with intensity of the bulb the photoelectric current increases. So what are the outcomes of this experiment? That the photoelectric current, it is directly proportional to the number of electrons emitted, and number of electrons are directly proportional to intensity of incident radiation. That means if we are having more intense bulb, I am definitely going to get more power, or I can say I am going to extract more current from a more intense bulb compared to a less intense bulb. This is the outcome of this experiment. Okay, what does we mean that if I am saying I am having a 100-watt bulb, what does that mean? It means that I am having 100 photons. I am having 100 photons from that bulb per unit time, and I am but if I am having 100 photon, and we already know that energy of one photon is fixed. And also if I am saying I have a 500-watt bulb, what does that mean? I am having 500 photons per unit time. So again here in this section also I know that energy of one photon is fixed. So I say that whether I have a 100-watt bulb or a 200-watt bulb, I have energy of one photon fixed. So let us see in the next section how this effect, the effect is seen in the photoelectric effect.